you for attending this year's Advanced Manufacturing Summit. My name is Christopher Marion, and I am from SolidCAD up here in Canada. SolidCAD, if you're unaware, is an Autodesk Platinum partner that provides technical know-how for any type of solution that you may require. So my presentation today consists of showing mainly the Delcam product line user. That would be PowerMill, FeatureCam and PartMaker, PowerShape, and lastly PowerInspect, what their Fusion 360 entitlement provides them, and how Fusion 360 can fit into their manufacturing process. So without further ado, here is leveraging Fusion 360 into your PowerMill workflow. I chose the topic leveraging Fusion 360 in your PowerMill workflow simply because most PowerMill users have access to this powerful tool, yet do not know much about it or how they can use it in their day-to-day operation. During this session, we'll talk about some of the important subscription benefits a PowerMill user receives, what PowerMill and Fusion 360 are in the scope of Autodesk manufacturing offerings, and finally, we'll go through a live demonstration on a possible solution on using both Fusion and PowerMill in a possible customer scenario. So my name is Christopher Marion, and I am a CAM specialist for SolidCAD here in Canada. I will be providing the technical presentation for the next hour or so and answer any questions that you may have towards the end of this session. Just a quick introduction of myself. I worked in the manufacturing sector for about 20 years in the tool and die industry, mainly working as a machine programmer and designer before joining Delcam back in 2015. I then worked directly for Autodesk throughout the merger in 2016 until I joined SolidCAD last September. For those of you that are not aware, PowerMill is Autodesk's premier CAM solution for driving your milling tools. It consists of high-end roughing strategies and solutions, powerful computing that results in fast toolpath calculation, advanced toolpath editing options, dynamic 3+2 machining options, fantastic 5-axis control, turning in a milling environment, driving industrial robots, and lastly, open API and macro language for easy automation. So here are some of the entitlements of what a PowerMill user receives with a subscription seat of the software. Probing, toolpath strategies for additive and hybrid manufacturing, some cloud-based collaboration tools, cloud storage and accessibility, and lastly, a seat of Fusion 360. So with that, what is Fusion 360 then? Well, Fusion 360, if you're not aware, is a fully integrated CAD, CAM, and engineering solution that allows you to take your ideas to life with design tools like sketching, 3D modeling, surface modeling, generative design, and more. Once we're done with the design, we can run some analysis tools on our parts to make sure the parts are not going to fail under different types of stresses and loads using some of Fusion's engineering tools. Lastly, we can physically manufacture this part in a variety of different types of processes like milling, turning, 3D printing, and more. So let's look at a possible scenario where a large corporation is looking for a company to manufacture some of the parts for their door lifting systems. In this case, Doormasters has issued some contracts to some local companies to handle supplying a large quantity of drive chain components. So Border City Machine has won the contract to manufacture these parts. This company is equipped with a few pieces of metal cutting equipment, their Haas ST30, which only has turning capabilities, and their Haas UMC 750 that can handle the more complex 5-axis milling. This Sprocket requires a large amount of turning and milling, so they will need to incorporate both pieces of equipment into this production run. Now, PowerMill does have some turning, but it really doesn't support these type of multitasking centers. But since they're on subscription, they can use Fusion 360 with an available post-processor found online to turn these parts and then move them over to their Haas UMC 750 to finish off the milling process. Okay, so since the initial manufacturing stages of our Sprocket will be on the turning side, let's begin by looking at Fusion 360 first. So if you've not seen Fusion, let's just take a quick tour. The far left-hand side is our data panel. Think of this as Fusion's file explorer. So any projects or any files I might be working on would be stored over here. Another nice aspect of the data panel is the collaboration tools. So if I were to, say, drop into this directory, I could always right-click on one of these files and share a link so that others can view it and collaborate with myself. So at the very top, showing that we're working in the design workspace, we're working with solids. and I have creation tools, modification tools, and I also have some inspection tools. If I wanted to jump over to surfacing, it would just be a matter of activating that tab, and I would have surfacing options. If I wanted to drop over to a different workspace, it would just be a matter of accessing this menu and selecting from one of the available workspaces here. Project Browser, this will store any items that I bring into this project or any items that I might have created in this project. The opposing corner on the top right-hand corner is our standard Autodesk View Cube. So it's just a manipulation tool by clicking on these interactive tiles, which will move my model around the workspace. The very, very top right-hand corner, if I click on my image, allows me to access the Fusion 360 preferences, and I can make any changes here and store them for later use. We also have some other viewing options towards the bottom of our interface. And lastly, if I right-click out in the graphic space, I also have shortcuts located in this pinwheel menu. Okay, so let's begin by saving this project. And I'm going to save it in my jobs file directory. And let me just access it here. Let's expand this. And I'm going to store it in job 0006. And let's just call this Sprocket Turning and save. Okay, so before I begin, what I am going to do is go into my master files. Underneath turning chucks, these are where I store all of my machining components. And the Kitagawa external chuck, I'm going to right click and insert this into the current design. Okay, so we can see the file gets imported in. One thing I am going to do, since this is linked to the original, is I'm going to break that link to keep this original to this file. And also what I'm going to do is I'm going to ground this chuck so I cannot move it. Okay, so in the chuck file, we can see all of our components to our chuck, and I also have some stock located in the chuck jaws. So let's go ahead and import our sprocket for machining. So there's a variety of different methods I could utilize. In this case, what I'm going to do is insert a derived file. So I'm going to go into my customer files, underneath door masters, my chain assembly, and I'm going to click on the sprocket. And it's actually going to open up this file in a separate window. And I could pick and choose which pieces I want to bring into my project. In this case, I'm going to select the entire sprocket. And we can see the sprocket gets imported into my design, but it's not exactly where I need it to be. So let's just right click, move, and I'm just going to drag this out of the chuck. And I'm going to rotate this 90 degrees. And then I'm going to move point to point from the back of the chuck. Let's make sure I got that in the correct spot. So from that location to the back of my stock, like so. And then I'm just going to move it off the back by, let's go 100 thousandths. And okay. So we can see that the sprocket is much too large for the stock, and the jaws are actually embedded into my sprocket component. So what this chuck file has is the ability to change the stock sizes interactively. So I'm going to go up into this expression and change this from 6-inch diameter stock to 10-inch. And we can see the stock grows, and it actually pushes the jaws out to the outside of my stock as well. And the stock length, I've got it set to 4 inches. I'm going to change this to 2.5. And okay. So this is going to be a representation of my stock. And last but not least, what I am going to do is also ground my sprocket so I don't accidentally move it. So let's just right click and ground it. So now I can't accidentally move any of my components away from my, my chuck. Okay, so since we've got the design portion down, let's jump over into the manufacturing space. Okay, so the very first thing we're going to do is create a setup. So a new setup. And we can see that the stock by default encompasses both the chuck, my stock, and the part. So the first thing I'm going to do is just go to the machine, and I'm going to select which machine center this is on. This is just going to give Fusion some directive as to which post I'm using and some other setup items. There we go. And then what we're going to do is jump over to stock properties, and I'm going to change this to from solid, and I'm actually going to pick that solid there. Let's go back to setup. And before I go any further, I'm just going to access my models over here. And I'm just going to turn off the stock. Okay, so the model that I'm working on is going to be this sprocket. And I'm going to turn on spun profile. The chuck from solid. Let's just pick some of these components. Like so. So the coordinate system, I'm going to pick my z-axis, and you can see it automatically places it in the center of my part, like so. And the origin, I don't want it on the stock. I actually want it on the front of my model, like so. So if I look at it from a side view, we can see that the stock is actually over top of my model. So I want my coordinate system to reflect that. And then also, we can see this green indicator as to where the back of my chuck is. So I'm picking from solid. I'm actually going to make this a positive value to stay off the front, like so. So we've gone ahead and created our setup on our part. Let's go ahead and create some toolpaths. So perhaps the very first toolpath I'm going to create is a facing operation. So I can access some operations here, or if I drop this menu down, I'm going to have the full scope of turning toolpaths. So let's go ahead and do a face operation. First thing I'm going to do is select the tool that I'm going to use. So I'm going to go into my Haas library, and I'm going to go ahead and pick my turning tool. Okay, so it automatically finds the stock, it automatically finds where the turning tool needs to get to towards the center of my part. So everything looks good here. The only thing that I think I am going to change is just my cutting speeds and feeds. So I'm going to change my surface feed to 400. And I'm going to change this to 0.015. And OK. Okay, so there's our first operation. Let's go ahead and turn this portion of the stock away. So underneath turning, let's choose a roughing strategy. It's going to use the same tool. You notice that the speeds and feeds here have updated to what I just placed in the last operation. That's fine. So the front of my model, the clearance plane, and the back of my model, in this case, it's looking at the back of my model. So I'm going to change this to selection, and I'm going to pick this front face. So this is going to represent the turning location. So outer radius will be stock. The inner radius, I'm going to change this to selection, and I'm going to pick that location there. I'm going to jump into my passes page, and the maximum depth of cut is set to 0.047. I'm going to change this to 0.75. And I'm going to make these even depths of cut. And let's go ahead and hit OK. Okay, so we've quickly identified two operations. Let's just quickly do a simulation to see what we have. So let's right click on the setup, simulation, and I'm going to turn on the stock. And right now I've got a comparison method turned on. This will show me if there are any gouges or any excess amount of stock. Okay, so there's our face operation, and now it's doing the initial roughing of our excess amount of stock. Everything looks good there. Let's go ahead and hit close. Now that was a roughing operation. We still need to finish this profile. So I could begin by selecting a finish operation here, or what I could do is actually right click on this toolpath and create a new derived operation and finishing. And what this is going to do is retain all of the information from my roughing into my finishing. So this is going to represent my outside turn, my inside turn, and any of the leads and links that I might have stored in there as well. So since we're finishing, I'm just going to change my cutting parameters. Let's go 7 thousandths. And OK. Okay, so let's kind of deal with the center portion. So I know that I've got a bunch of stock here I have to remove, and I also have a hole that's opened through my part. So maybe the very first thing I'm going to do is drill through this stock. So let's go up into drilling, select the drill operation, and let's go ahead and select my drill. So in this case, I'm going to go back to my Haas library. And I'm going to go ahead and pick this 2-inch inserted drill. Okay, so geometry, selected face. I'm going to go ahead and select this inside portion. For the heights, I'm going to change the top height to be the model top. And the bottom height, I'm going to go through the stock, so stock bottom. And I'm going to make sure the tip drives all the way through. So the breakthrough depth is set to 0. I can manually place a value in here, or I can actually right click, edit the expression, and I also have access to all the different types of parameters. So if I just start typing tool, it's going to give me some parameters that I can select. So in this case, I'm going to select the tool shaft diameter, and I'm going to times this by 10%, which would represent a 0.125 value here. Okay, so drilling through the stock, and the next operation, what we'll do is bore out these operations in a roughing and finishing fashion. So let's go back to turning, profile roughing. This time I'm going to select a different tool. I'm going to select my boring tool. Let's go back to my Haas library, select my boring tool. So speeds and feeds, let's change this back to 400. And the cutting feed, let's change this to 15 thousandths. Okay, so let's go ahead and change the back portion to the stock back. And I'm actually going to extend that or offset it by 1/8 of an inch. So for the radii, I know that I drilled the inside portion with a 2-inch drill. So the inner radius, I'm going to change this to diameter, and I'm going to change this to 2 inches. and tab in so we can see that this is where we're going to start. And the outer radius is actually going to be the selection of my model. So this case. The clearance, I need to supply some clearance here. So again, I'm going to change this to diameter. And I'm just going to change this to be slightly smaller than my 2-inch. So maybe 1.8 inch. Let's go into the passes tab. I'm going to change this to 50 thousandths. And I'm going to make these even depths of cut. The last page, which we haven't looked at yet, are all my linking options. I'm just going to leave all these default. Okay, so I've got all of my rough operations for bore, and then I'm tangentially moving past the stock. Now, one thing I'm going to be aware of here is that I can see the tool path segment kind of veering off on an angle, and same thing in this groove. That's because I've got some undercut options turned on. If the tool can access those areas with the shape of my tool, it's going to gouge those that part of the stock out. So let's go into the edit options. I'm just going to go into linking, and I'm going to change, underneath passes, I'm going to change this grooving options to do not allow any grooving. So that should now keep the tool straight. Since we're going to cut this groove in a milling operation later on. Okay, so last but not least, let's just go ahead and finish that. So I'm going to use the same method I did before by right-clicking, create a derived operation. And again, it's going to keep all of the geometry, everything selected, including the tool. So one thing I am going to do is just change the cutting revolution, speeds and feeds, to my finishing value of 7 thousandths. Let's go ahead and hit OK. So it is generating a warning here. If we were to click on the warning, it might give me some information as to where the warning resides. So in this case, it has something to do with the lead out. So let's just jump into the strategy here and go into my linking tab. And I'm going to change the lead out to be separate from my lead in. And the lead in, actually, what I'm going to do is change this to 0. So I'm going to come straight on. Okay, so now we've got different types of lead in, lead out, which removes that warning. So let's go ahead and simulate this from beginning to end. Simulate. I'm going to change the mode now from comparison to material, a different type of simulation. And let's go ahead and hit play. So you can see the timeline at the very bottom indicates which operation we're in. If there were anything we should be concerned about, it would show up in red, which I don't see any at this point in time, so that's a good sign. Okay, so now we're roughing the interior portion of our sprocket. We've drilled out the middle first, and then we'll have the finish operation shortly after this. So everything looks good, no warnings generated, pretty happy with that. So what I am going to do though is before we move any further is I'm going to right click on the setup underneath stock. I'm going to save this stock so we can import this into PowerMill later on as a continuation of stock. I'm just going to save this as stock onto my desktop. I'm going to replace it and close. So next what I'm going to do is I'm going to send all this information out to the machine, to the operator. So let's right click on setup. And I'm going to generate a setup sheet. So let's go ahead and select the desktop. I've got this Sprocket job folder. I'm going to save that there. And it's going to indicate to me the stock dimensions, the part dimensions, and the total runtime of 32 minutes. And all the tools being used in this project at this time. So I'm a little bit concerned with the runtime of 32 minutes. I think we can do better than that. So let's close the setup sheet. And what I am going to do is select all of my turning operations. And let's just remove the drilling operation here. And I'm going to right click and I'm going to bring this over to my compare and edit options. And this will allow me to make some changes across the board or within just one operation without actually going into each operation underneath the edit options. So maybe the first I'm going to look at is my feed. So I've got my cutting feed rate of 15 thousandths per revolution for facing, roughing, and 7 thousandths for finishing. So I know that I can probably be a little bit more aggressive with the roughing, and I'm going to make this 0.02 or 20 thousandths. And I'm also going to change the step down. Sorry, that's going to be depth. So depth of cut, 75 thousandths. I know I can push this to 100. And for my boring, I know I can push this to 75 thousandths. Let's go ahead and hit OK. I'm going to hit yes. And let's regenerate that setup sheet. Okay, so now we've reduced that time from 32 minutes down to 21. And I can start tweaking this if I want to start shaving some more time off. But I'm pretty happy with what I see here. So I'm going to go ahead and close that, send this to the operator. Now let's go ahead and generate some NC code. So I'm going to go ahead and click on NC program. The program name, I'm going to leave that as the default. The location, I'm going to click on this, and I'm going to actually save it in that same directory as before. The post, we're using the Haas turning post that I found online in our Autodesk HSM post library. Let's go ahead and hit OK. So it's giving me a little bit of a warning that I can't save the name with a letter. So let's go ahead and close that. That's something within the post. I'm going to remove that and hit OK. Let's go ahead and post that out. Okay, so I am generating another warning here. So work offset has not been specified. So let's go ahead and go into the setup. Underneath post process, I'm going to change this to 1. Let's repost that out. And last but not least, I'm actually going to go back into this NC program. Underneath settings, I'm going to turn on open NC file in editor after I post so I can visualize the code. Okay, so that's automatically going to open it up in my specified text creator. In this case, it's Notepad++. And if I want to review any of the code that's been spit out by Fusion, I can go ahead and do that. Okay, I know everything looks good here, so let's go ahead and close that. And I'm going to go ahead and save this project once again. And let's go ahead and bring everything over into PowerMill. For those of you who have not seen PowerMill or know what PowerMill is, it is a standalone CAM package. It's based off the ribbon type interface, pretty persistent in any of the Microsoft products. So if you're familiar with using Word or Outlook, it's basically the same look and feel. I'm running the latest version, which is 2021. A quick tour, we have the Project Explorer on the left-hand side, kind of the same as what we just saw in Fusion with the project browser. So it's going to populate with items we import in or items that we create along the way here. On the far right, opposing side, we have the viewing toolbar. This contains
model manipulation tools as well as some model interrogation tools. The viewing toolbar, we just saw this in Fusion as well. It's basically the same way. You use these interactive tiles to kind of manipulate your model across the graphic space. At the very bottom of the interface is the status toolbar. This just gives me some feedback as to units of measure and maybe even where my mouse pointer is in the Cartesian space. Okay, so let's begin here. I'm just going to go ahead and import that same Sprocket file into PowerMill. Okay, so let's go ahead and import that Sprocket. It's going through the translation. And let's just zoom this in. And I'm going to change my shading over to multicolor. So quick glance, the model itself is upside down to the orientation I want to work in. So the very first thing I'm going to do is create a new UCS or a work plane. And let's just go ahead and swap these like so. I'm going to rename this work plane. So perhaps this is going to be G54 on my machine. And we'll go ahead and activate it. All right, so after this, we're going to go ahead and import that STL file that we exported from Fusion to represent the stock after turning. So we're going to go into the block properties. Let's go ahead and search for that file and accept. I'm just going to set up some safe areas here real quick. And then we're going to go up into my custom tab, the Haas ribbon over here. And first things first, I'm just going to import my tools into my projects, the tools that are associated to this machine center. And they're all neatly categorized in these folders. And I'm also going to bring in my fixture for this using the Vice Import add-in. Now, this add-in has a lot of standard vices, like your Kurtz, your Girardis, and it also gives us the ability to add our own custom vices or fixtures like I've done here. So I'm just going to pick the faces that I want the jaws to clamp against, which is going to be this bottom face that has been finished in Fusion, and I'm going to import. And as the import process goes, it's going to bring all the components for this fixture in, and any of the moving components is going to set the clamp against that the faces that I selected against. So that's been done. Before we begin any tool pathing, I'm just going to go ahead and modify this coordinate system, which is my simulation work plane. We'll talk more about this in a minute, but I'm just going to go ahead and edit this so it's on the bottom of my plate, like so, and there we go. All right, so let's go back to the Home tab. And if I wanted to start creating some toolpaths, I've got my tools imported into this project. Maybe at this point in time, I'm just going to go ahead and save this. And again, I'm going to put this on my folder on my desktop, which is here. And I'm just going to call this Sprocket Milling. It looks like I might have spelled it wrong. There we go. So I'm going to go up into the Toolpath Strategy Selector. The Toolpath Strategy Selector gives me all kinds of strategies for roughing, off of curves, feature machining, a wide library of different types of finishing strategies. If you are working in the mold die industry, we have a dedicated toolpath strategy for cutting ribs, strengthening ribs. We also have dedicated strategies for machining blisks and ports, and some probing as well. So just to move things on a little bit quicker in this demonstration, if I go to my Sprocket drilling folder, I've already got some toolpaths that I've saved the strategies for. So I'm just going to select this face mill operation. And it's automatically going to pull the tool out of my available tools here. And all of the speeds, feeds, everything has already been set up or saved as how I like them. So in this case, I'm going to call this one face top. Let's go ahead and calculate it. Okay, so let's go ahead and finish this step. So before I do that, I'm just going to go ahead and extract a curve from the model. Select this edge. Let's just accept it. And then I'm going to go back to the same location I was at with the strategy selector. I'm going to select spiral step. Again, this is a strategy that I saved. I know it works, and I want to regurgitate it for upcoming projects. Okay, so I'm just going to select the curve that we're going to use. I'm going to make sure I'm cutting on the appropriate side. So let's go ahead and reverse that. And everything else is set up. I'm just going to change the name of this. Oops, spiral step. Some fat fingers going on here. There we go. And let's go ahead and calculate. Now, one thing you need to be aware about how PowerMill calculates its toolpaths is that all the green segments that we see here are cutting segments. All the other colored segments are non-cutting segments. So anytime we want to change the behavior on how we lead out or lead in, or change the way we wrap it to the part, all of this stuff can be modified after calculation. So we don't really need to calculate the toolpath once again. So I can do this by going to the Toolpath Edit tab, Toolpath Connections. And if I want to modify the behavior on the lead out, I can go into the lead out page and then just change the behavior here by changing the radius from 1/2 inch to 1/4 inch and apply. And you'll see that it automatically updates. So moving forward here, let's go ahead and look at these 5 drilled locations. So I'm just going to extract these from the model. So I'm just going to select my model here and extract the holes from the model, or our features for that matter. And I'm going to go back to the Toolpath Strategy Selector, and I'm going to go ahead and select this method. So this Sprocket holes is a drilling method, and the drilling method is easy for me to create. It just really is a methodology on how I want to attack certain holes on my model. So in this case, if PowerMill detects a hole that is a certain diameter, in this case it's 0.667, it's going to apply my processes to that those locations. So I'm just going to go ahead and hit apply. And it's going to do a spot drill, a drill, and then a helical operation for the counterbore section. All right, so moving forward, I just want to be able to at least manage my stock, because at this point in time, all I see is the model that we imported in, but I don't see the history on what we've done from this point on. So I'm just going to go down to stock models in my Explorer. I'm going to create a stock model, and I can name this whatever I like. So let's go ahead and call this Sprocket stock. And I'm just going to accept that. I'm going to take these 5 toolpaths and I'm going to add them to my stock model. And then let's just go ahead and calculate this to update my stock, kind of what I would see on the machine side. Okay, so if we look closely, we can see the holes have been subtracted from the stock, as well as the facing operation in that step. I could take this another step further and go into a drawing option to show me the remaining material. And now we can really see the areas that we need to kind of focus on. So let's go ahead and do that. Again, I'm going to go back up to my strategy selector and kind of moving things forward again. I've saved a roughing strategy just for this. That's an adaptive roughing strategy. And actually, this adaptive roughing strategy has been taken from Fusion 360 or HSM. It is their adaptive roughing strategy. So PowerMill actually has 2. It has the Delcam adaptive strategy and also has the HSM adaptive. Okay, so I've got all of my speeds, feeds, step over, step downs stored in here. I'm just going to change the name to maybe rough. And let's go ahead and hit calculate. Oh, so we are getting an error because PowerMill's looking for the reference for rest roughing. So let's go up into that page and let's make sure we apply our stock model. And to the current point in time, we want PowerMill to look at this model. So if you're not familiar with the adaptive roughing strategy, it's just the ability to take a full depth of cut with your cutting tools with a smaller radial side cut. You're able to take a consistent feed rate, and you're never really going to break the engagement angle of the tool. So this, you're going to get better tool life and better surface finish. Okay, so let's go ahead and close that. If I were to zoom in real quick, I can see the toolpath segments on each one of these little cutouts. If I want to visualize it, I always just right click, simulate this toolpath from start, and I get a good representation as to what this toolpath is doing in these regions. Okay, so I'll just pause that and go bring that back to the beginning. What I'm going to do is take this toolpath and add this to my stock model just to update my stock so I know exactly what I have to take care of here, which now we can see we've got some stock on these walls. We've done a good job of roughing out the material in between. So let's focus on that. Let's finish these walls. Now, if I look at it from a side view and really zoom in here, I can see that the walls are undercut. So I'm going to go ahead and use a 5-axis strategy for this. In this case, I'm just going to turn off the stock model for now. And let's go ahead and look at this from the side view. And I'm just going to select all of those surfaces in between. And let's deselect the surfaces on top. I really only want to focus on these surfaces in between here, these outside surfaces. So let's go back to the strategy selector. So this time, what I am going to do is go into my finishing strategies, and I'm going to pick a swarf finish. So swarf is going to take the side of the end mill, and it's going to force the side of the end mill to cut these surfaces. Even though they're undercut, the ruled surfaces will dictate the tool axis movement based on the tool that we're using. Okay, so I'm just going to kind of go through some of these forms here. So underneath limit, I'm going to make sure the tool can cut outside the stock, remove my Z limits. Let's go into the swarf finishing page. I'm leaving 0 stock. Position, my tool is going to cut the bottom of what we selected. I've got an offset of 100 thousandths. If I want to change that to 1/8 of an inch, it's going to force the edge of my tool past the bottom of that wall by this amount. Let's change this toolpath name to swarf, and let's go ahead and calculate that. Close. Okay, so let's go ahead and look at this toolpath. Now, as I mentioned before, just to kind of reiterate what I mentioned, is that I've got these lead in, lead out moves. This might not be optimal in my case, so I don't need to recalculate this toolpath. All I need to really do is go up to toolpath edit, toolpath connections, lead in. I'm going to change this to horizontal arc. I'm going to come off 45 degrees at 1/4 of an inch. I'm going to turn off my separate lead in. Let's go ahead and make both lead in, lead out the same and apply. Okay, so you can see how quick it is to update non-cutting segments in PowerMill. So let's go ahead and focus on this chamfer region, because I know that there's a little bit of stock here. So to do this, I'm just going to go ahead and extract a curve on the bottom of this edge. So let's go create a pattern, and we'll go into the pattern tab. And again, let's extract that edge and go back up to my home tab. Underneath strategy selector, I actually have a strategy saved for this, Sprocket Chamfer. So the only thing I really have to do is just change the curve in this case. And let's make sure we're cutting on the appropriate side. So on this side, and let's go ahead and calculate. And let's go ahead and change this to chamfer. And I'm just going to check something real quick. And that looks good. Okay. Lastly, all we really need to worry about is there is some stock in this region. There's like an O-ring seal that we need to cut out. So what I'm going to do is go select an appropriate tool. So I could use a form tool. In this case, since we have our UMC 750, which has full 5-axis capabilities, I'm going to go ahead and select this 1/16 ball nose tool. And I'm going to select this surface. And we're going to go up into the strategy selector once again. Underneath finishing, I'm going to select surface finishing. And surface finishing allows us to cut the inside of the surface, the internals of the curves that make up the surface. So a nice feature on this toolpath strategy is I'm able to see a preview of the toolpath before I actually calculate it. So right now, if I kind of zoom, you can kind of see the pattern that it wants to project is going in the direction that I don't want. So I'm going to go over to pattern and change this over to a V and uncheck spiral. Let's do another preview. And you can see it's cutting in the right orientation, just maybe not the right direction. I want to climb cut, so I'm going to change this as well. And I'm also going to change this to one direction. That looks better. Let's just change the step over real quick to 10 thousandths. Okay, so we can see, got a good idea of how the toolpath is going to cut before we actually calculate. Before I actually hit calculate, what I am going to have to do though, since we have an undercut region, is I'm going to have to change the tool axis in order to reach that location. I'm just going to change this quick and easily to from a point, and I'm going to put a theoretical point out in space. And let me just call this one groove. And let's calculate that. So we've got our toolpath. Now, the only thing that we might want to change is just the way it leads in, leads out, like I mentioned before. So let's close this. Let's go back to toolpath edit, toolpath connections. And instead of maybe a horizontal arc, I'm going to do a surface normal arc and change the radius to something a little bit smaller. And apply. And lastly, what I might do is instead of retracting with a skim move, I'm going to change this to a circular arc. And let's just change this to 1. Okay, looks better. Now, what we can also do is that I've got the toolpath kind of jumping around. I'm just going to look at this in a top view. Let me just unshade the tool a bit. Toolpath edit, move start points, and I'm just going to make sure all the toolpath start and ends cross that location, like so. One last thing, let me just, actually that looks good. I'm just going to leave it the way it is. Let's accept that. Yeah, it looks good. All right, so we might want to visualize this on the machine, as with maybe our swarf cut, just to kind of visualize how the machine reacts. So what I'm going to do is go into my Haas ribbon, and I'm going to click on this button to import my machine tool. It's going to set my posts, post location, everything up for me. And if I were to right click on this groove, simulate from start, and let's slow this down a little bit, step it forward, we can see how the machine tilts. And everything looks pretty good in this vantage point. I'll just zoom in here so we can kind of see it. All right, so I'll just pause it at that and go back to the beginning. So the benefit of having a machine sim like so is that we get to really see how the machine's going to react from toolpath to toolpath. And if there were going to be any issues, PowerMill would warn us with any type of limitation. So if we're hitting an axis limit of some sort, PowerMill will let us know. If we hit a collision between, say, the spindle and the model, PowerMill will also let us know if there are any issues. So let's go ahead and create an NC program. And I'm going to call this one milling, so I know exactly what this is for. And I'm going to take all these toolpaths and I'm going to add them to my NC program. And I don't have some numbers attributed to some of my tools, so I'm going to go over to tool numbering and just make them sequential. So I'll make sure that when I run these on the machine, I'll set these tools up in the appropriate locations. There's a few things to be aware of in PowerMill, because PowerMill, when it calculates toolpaths, gives me these status lights, and these status lights represent safety statuses. So white represents a gouge check against the model. Yellow represents it hasn't really done any checks. So before I run this on the machine, I want to see some nice blue check marks there, what represent this portion of my tool setup is safe. There are no collisions. And I also want to bring this up to the highest standard, which is an NC verification, which gives me a check that there are no collisions during the machine movements at all. So let's go ahead and do that. So I'm going to right-click on this NC program. Let's go to verify. And I'm going to verify all of my movements, collisions. I'm just going to leave everything default. And let's verify. So if there are any issues, we can see that all this toolpath lights are lighting up blue, which indicate that there are no toolpath collisions. But I am getting a warning here about the machine tool being different in the post file than what I actually see here. And that is because this machine tool has an extra axis just for the simulation for the tool changer. So I can ignore that. And I got that nice green, oops, let's ignore that again and close. So now I've got that nice green check. I should be able to run it on the machine without any issues. Let's go ahead and post this out. So let's write this. No issues. We get that same little warning. Not a big deal in this case. So let's go ahead and close it. And just for the operator, I'm going to go ahead and send out some setup sheets like I did in Fusion for this setup. So I'm going to go back to my custom ribbon, run the setup sheet macro, and I'm just going to give myself a nice view. Maybe what I'll do is I'll just activate this toolpath. Okay, so this is going to write all the information about this project onto this custom setup sheet for this company. We've got all the information about the project on this page, and then the next page has all of the information on all of the toolpaths that we just gone ahead and calculated in PowerMill. So I'm just going to go ahead and close this, and we'll go back into PowerMill real quick. And I just want to thank everybody for showing up. I hope you kind of get an idea of, what PowerMill can bring to the table for you Fusion users, or vice versa, what Fusion can bring to the table for you PowerMill users that have access to it.
So I appreciate everyone coming out today and taking some of your valuable time to watch this presentation. I'd also really like to thank Autodesk for giving us this platform. It's been a very difficult time, as we all know, so having a virtual venue to showcase some of this great technology has been fantastic. Please go ahead and ask any questions. I'll do my best to answer them in the time that we have remaining. If we need to, we'll take it offline, and I'll send you some responses by email if necessary. So go ahead and enjoy the rest of your time at the summit and take in as much as you can. Thank you very much.